Hello everyone, welcome to Emmanuel Tutorials. In this video, we'll be seeing how to find the minimum spanning tree of a graph using the Prim's algorithm. So we'll start. For this video, we have taken this graph as the example. So this is the graph, it has 5 vertices. So to solve this problem, we have taken some variables for our simplicity. One is UV, which is the set of unvisited vertices in the graph. NE is the neighboring edges. We'll see what it means. So we can start now from the graph. This is the graph. We have initially we haven't visited any vertex. So all of the vertices will come into the set UV. And we can start with any arbitrary vertex. In this case, we have taken 1. So 1 is the first vertex that we'll be visiting. So we saw that we had two variables, NE and UV. So NE is the neighboring edges. So these neighboring edges we consider only from the visited vertex. So in this case, we have visited vertex 1. So the neighboring edges to 1 is 1, 2 and 1, 3. So we have listed it here, and their associated costs also we have written down. So for 1, 2 the cost is 1, and for 1, 3 the cost is 3. And now since we have already visited 1, we remove 1 from the set of unvisited vertices. Once that is done, we will be proceeding to find the next vertex in the MST. So now of these two edges that we have considered, we'll be taking the one with the minimum cost. So out of 1 and 3, 1 is the least, so we consider the edge 1, 2. So by including this in our MST, we are visiting vertex 2 as well. So we have taken 1, 2, and in this process we can remove 2 from the set of unvisited vertices. So currently in our MST we are having this edge 1, 2. So we have implicitly we have visited vertex 1 and vertex 2. So again we'll be following the same process. We'll be having the set of edges and the associated costs. So for 1 and 2, the neighboring edges we can see it is 1, 3, 1, 2, 2, 3 and 2, 4. But we have already taken 1, 2 in our MST, so we don't need to reconsider it. So we have 3 other edges, 1, 3, 2, 3 and 2, 4. So 1, 3, 2, 3 and 2, 4. So for 1, 3, the cost is 3. For 2, 3, the cost is 3. And for 2, 4, the cost is 6. So we have written it down. Now this is for vertex 1 and this is for vertex 2. So that's the reason I've divided it. Now from this we'll have to find the least cost. So since both of them are 3, we can take any one of them because both of them would finally be visiting vertex 3. So in this case we have taken 1 and 3. So in our MST now we'll be having 1, 3 and its associated cost also we have written. So after this step we have visited the 3 vertices 1, 2 and 3. Again we'll be following the same steps. Again we'll be having the set of neighboring edges, the associated costs. Now we have visited 1, 2 and 3. So we will be finding their neighboring edges. 1, 2 is already covered, so we can just mark it. 1, 3 is already covered, so we'll have to consider the other ones. So this is 1, this is 1. So we have written 2, 3, 2, 4, 3, 4 and also 3, 5. So from 3 we have these 3. From 2, since this is covered, we can't take it, and we have these 2. So of these again we'll have to find the minimum cost. So from this if we see the minimum cost is 2. So we'll have to add that edge in our MST. So here we have added it. So that edge 3, 5 has been added. So since we have included the vertex 5 in our MST, we can remove it from the list of unvisited vertices. So 5 is gone. Now we only have to visit one vertex. Again, we'll be listing down the set of neighboring edges and their associated costs. So from this, now we can again mark the one that we have visited. We have visited 3, 5. So this is done. Now we we have the remaining edges, so we have listed them down. Of these, we don't have to consider 2, 3 because 3 is already visited. What we'll be taking into consideration is only these 3 edges. So of these, the minimum one is 4. So we take that edge, which is 3, 4, and we can empty the set of unvisited vertices because we have visited all of them. So this is our final MST. So what we need to take into consideration, since it's a tree, we should not include any edge which should create a cycle in the graph. So, and this would be the final cost. So 3, 5 was 2, so it would be 1 plus 4 plus 3 plus 2, which is 10. So this is the final MST that we get for this graph. Hope you all understood how to solve the Prince algorithm. If you like the video, please like and share the video, and also subscribe to Emmanuel Tutorials to get notifications of the videos that would be coming later. Thank you.